Bismillah ar-Rahman ar-Rahim. In the name of God, the most gracious, the most merciful. Welcome to another lesson with the lady Khadija radiallahu anha online college. Live lesson, A-level maths, year 2, pure maths. Today we are looking at binomial expansion when you have double brackets. So you have the one expansion, that's going to be your first bracket, but you've also got another bracket next to that, and you're going to have to work with that. So this is, if you're working through the book with us, then it's chapter 4, example 4. That's the edXL Pearson Year 2 UK A-level book. Okay, Bismillah ar-Rahman ar-Rahim. In the name of God, the most gracious, the most merciful. Let's start with a quick warm-up exercise. So taking you back to your GCSE. And if I said to you, can you expand this? Then I'm sure you'd have no problem. But what if I said to you that I just wanted the x squared term? Just the x squared term. Well, that's even easier because that means that I don't want the whole thing, so you don't have to expand everything, but you just have to choose the right bits of the expansion, just the right bits to end up with the x squared term, and you can leave everything else. So in this case, it'd be quite easy. You would just do the x times x bit, which would give you x squared. So that would be the x squared term, just x squared on its own. So let's try a slightly more complicated one. Let's say I had 3x plus x squared in one bracket. I had 2 plus 4x in the other bracket. And again, I'm just looking for the x squared term, just the x squared term. So have a think for a few seconds. Which part of that expansion would you need to do, or sometimes which parts? But the idea is that you don't want to do all of it. That would be too much. You just want to pick out the bit that's going to give you just the answer for the x squared term. So have a look at that. Okay, hopefully you've spotted that if you do the 3x times the 4x, that'll give you an x squared term. Would anything else there? Yeah, the x squared times the 2, that would also give you an x squared term. What wouldn't give you an x squared term? The 3x times the 2, that would be no good. The x squared times the 4x, that wouldn't give you x squared anymore because you're going to take it to x cubed. So just if you want the x squared terms, that's all you need to do, and that would be 3x times the 4x would be 12x squared, and then the x squared times the 2 would be 2x squared. So if you want just the x squared term, you'd end up with both of them added together, which would be 14x squared. So that's really the only skill you need to have in today's lesson on top of everything you've learned so far. So let's take a look. This is an example of binomial expansion with a double bracket. So we have example 4, if you're following the book. A function of x is equal to, and then we have a fraction 2 plus x over the square root of 1 plus 5x. So far it should look pretty good, and we want to expand this, but the question says we only want the x squared term. Find the x squared term. Okay, so the first thing we want to notice is that having a fraction isn't a very good idea. It's going to make things a little bit difficult. Also, the square root isn't really going to help with the binomial expansion, so we need it to be rewritten where the square root is instead as a power. So remember that the square root is really the power of a half, so we can rewrite this whole thing, and instead of the square root, we can have a power of a half. So that will be more like the kind of format we need for the binomial expansion. But then we don't like having the bracket on the bottom of a fraction. We really want to bring it to the top. So we can do that. Do you remember we just change the sign on the power? So instead of positive a half, it will become minus a half. So we can bring this to the top. And we can put it up here. But the condition is we have to change the sign on that power. So instead of positive a half, it becomes minus a half as the power. And then the 2 plus x, just to make sure that that is still kept together, we can just put brackets around that. Okay, good. So that's the original question, but just rewritten in a form that we can then apply a binomial expansion. So then what we want to do is really just focus in on the binomial expansion bit, which is this bit here, because that's the part that's got a power of a half, a fraction. It's also a negative power. So we can definitely apply the binomial expansion. The 2 plus x, we're just going to kind of leave hanging on the side for a minute. So let's say that we've got the binomial expansion formula and we want to apply it. So the 2 plus x can stay as it is. So can what we're calling it, which is the function of x. But we want to really apply the formula to 1 plus 5x to the power minus half. So what was that formula? Hopefully you'll recognize it by now, but it's 1 plus nx, and then comes the fraction bits, and that'll be an x squared term, and then an x cubed term. We have 2 factorial on the bottom, and n to the n minus 1. Here, because we only want the x squared term, we don't have to go more than this. So let's apply it. So let's use the formula in orange. So we've got 1 to begin with, which is great, easy enough, plus, and then we've got n times x. N is minus a half. Your x is this whole thing, which is 5x. So it's minus a half times 5x. I'll just put that in brackets as well. Okay, and then comes the next bit, which is now the n minus 1 fraction. So the n is minus a half, and then that gets times by n is minus a half, gets times by 1 less than that, so that's going to be minus 3 over 2. On the bottom, it's nice and easy, just 2 factorial is 2. And then it's x squared in the formula, but it's really 5x in the expansion that has to be squared. So that's 5x squared. Okay, let's use the calculator to tidy that up a little bit and work it out. So the 2 plus x can stay as 2 plus x. And now, if you want to use a calculator and just try to work out those bits at the beginning, so we'll have 1 stays as 1, then it's minus 2, a half, minus a half times 5, that's minus 2.5x. And then this bit will work out to be, if you want to just type, I'll give you a few seconds to type that in. Okay, it works out to be, as a fraction, 75 over 8x squared. Remember that the expansion does carry on to x cubed terms and x to the power 4 terms, so because we weren't interested in anything beyond the x squared term, we didn't do that, so I'm just going to put dot 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 just to make sure you remember that it does carry on. So dot dot dot, and let's close the bracket. So now let's take a look at using that skill that we did practice at the beginning. Can you spot, when I expand this out now, the 2 plus the x in the first bracket with the 1 minus 2.5x plus 75 over 8x squared in the third bracket, what will I end up having as the x squared term? Just give you a minute, a few seconds, type it into the chat box if you can. Okay, let's take a closer look. So to get the x squared term, just have your scan. We're looking for an x times an x. That would do it. So them two times together to get the x squared terms. One of the x squared terms. Is there anything else? Well, that's an x squared term. So if I multiply that with the 2, that will still stay as x squared. Anything else? No, you're happy that's the only things that will end up with an x squared term. So let's multiply that out. 2 times 75 over 8x squared becomes 75 over 4x squared. And then the x times the minus 2.5x would become minus 2.5x squared. And if you just simplify that, then you'll end up with 65 over 4x squared. So there is your x squared term. Okay, hopefully that was easy to follow. There was a second part to the question, which is going back to the original expansion. What's the range that it's valid for? So to find out what the range is, look at the binomial expansion bit that we did, and this, if there's a minus sign included, we have to include that, but here it's easy. The modulus of this has to be less than 1, so that means the range is, it's valid for the modulus of 5x being less than 1. The modulus of 5x is written like this with 2 lines on each side. Divide both sides by 5 and then you get modulus of x being less than 1 over 5. And that's it. Join me tomorrow for another lesson in binomial expansion. Assalamu alaikum wa rahmatullah. Peace be with you and the mercy and blessings of God.